So in lesson 5.1, I want to do a few examples out of the homework to kind of make sure we're on the same page. The first one we're working with is determine the area of the shaded region under the standard normal curve. So remember when we talked about z-scores, cumulative area is one of the things that we talk about. So if I can pull up my little chart here. Notice that in my tables, the cumulative probability or cumulative area goes from the left to the z-score. So we got to keep in mind that these z-scores that we have here represent the area under the curve from the far left to the actual z-score. So that's what we have going on here with that. So when I do my example here, notice that our z-score wants to find the area to the right. So the way we do this is remember the area under the curve is actually 1. So the whole area is 1. So what I want to do is find the area to the right. But when I do the z-score, it's going to be doing from the left. So let's go to the table and find the z-score of 1.62. So 1.62 is going to be this, looks like this 0.9474. So let's put that down. So this 0.9474 is actually this area over here. So it's actually this area. What I want to know is what this area is over here. But remember the area under the whole curve is 1. So if I take the difference between those two, the 1 and the area under the left side, that is going to give me my area under the curve to the right. So if I go 1 minus the 0.9474, that gives me the area to the right of the curve, to the right of the z-score. So if I can find my calculator. So if I type in 1 minus 0.9474, that's going to give me this 0.0526. So that would be the area under the curve to the right. So my next example is determine the area in which it's between two z-scores. So if the area is between two z-scores, what we do is we find the difference of those two z-scores. So remember the area of the first one, the negative 1.1 z-score represents the area from here to here. The area of the second z-score, the 1.4 represents the area from all the way over here, all that as well. So what we want to do is we want to remove this part over here. So that gives us the area between the two. So all I got to do is find the area for these two z-scores and take the difference between them. So let's see if we can find the 1.4 to start with. So 1.4 would be this 0.9192. So it's going to be 0.9192. And we're going to subtract the negative 1.1. Negative 1.1 is going to be that 0.1357. So if I use my calculator, we can go 0.9192, subtract then 0.1357. That's going to give me then this 0.7835. So that would be the area between the two z-scores. Again, that's our cumulative probability as well. So our next example is they want to find the indicated under the standard normal curve. So in your homework, they just give you to the right of z equals negative 0.34. So it's not a bad idea to actually draw yourself the picture like as I have here, draw yourself a standard normal distribution curve. The negative 0.34 is going to be over here somewhere. It's going to be just to the left of 0. What I want to know is the area that's to the right of that z-score. So they're wanting to know this area over here. So remember, when you do z-scores, they're doing it from the left. So to find the area to the right of the curve, to the right of the z-score, I have to use the 1 again. So I have to go 1 minus the cumulative area associated with the z-score of negative 0.34. So if I go back to my table, negative 0.34, let's see here, the 4 is up here, come down, negative 0.3669, so 0.3669. So 0.3669. So if I use my calculator, I can take the difference between those. So 1 minus 0.3669, hit enter. That's going to give me then this 0.6331. So that would be the area to the right of the z-score. So another example we have is a standardized exam scores are normally distributed. In a recent year, the mean test score was 1519, and the standard deviation was 311. The test scores of the 4 cents selected at random are given: 1920, 1290, 2240, and 1420. Find the z-scores that correspond to each value and determine whether any of these values are unusual. So let's just do one of these and go z equals, again, the formula was x minus the mean, x bar, over the standard deviation. So my first x was the 1920 was the student score. That was my sample. And I want to subtract it from the mean of the sampling, which was the 1519. And then I want to divide that by the standard deviation, which is 311. So if we slide that over, so I have this 1920, subtract the 1519, and get that answer. Divide that by 311. My z-score would be, looks like about approximately 1.29 if I round to the 2 decimal places. So I have my z-score. So that's kind of what we're doing there. All right. So I'll let y'all do the other 3 there. So another example we have is doing what's called a histogram again. We did this back in Unit 1, I believe. So let's review that again, see if we can put this together. So you're performing a study about weekly per capita milk consumption. A previous study found weekly per capita milk consumption to be normally distributed, with the mean of being 37.5 fluid ounces and a standard deviation of 7.8 fluid ounces. So you randomly sampled 30 people and recorded weekly milk consumptions shown below. So weekly milk consumptions. I'll probably drink, I don't know. I drink 8 ounces a day, 5 days a week. Yeah, I'm about normal, about 40 ounces a week. So if I put this data into the table, so we slide this to the right. So if I hit the stat button, go to edit, my table's already clear, so I don't have to clear it out. But remember, if you need to clear a list, you can go up to the L1 and hit clear. You also can go to the stat button and number 4, clear list, and you just tell what list you want to clear. If I want to clear L1, I hit second L1 down there and it'll clear L1. So anyway, I want to put my data in. So I'll pause my video for a second and see if I can get this data put into the to my calculator. So I've got my data entered. Now to create the histogram, remember you go to second stat plot. Make sure it's on. Make sure your type is the histogram. Make sure it's coming from list 1. So if I hit graph, it now kind of gives me my graph here. But this graph really doesn't jump out like any of these graphs here. Kind of looks a little bit, well, not really, maybe kind of close to this one a little bit. So let's see if we can make this work. Again, sometimes I may just put the data in wrong too, that makes this mess up. But so if we look at the window, one thing we have to pay attention to is the scale, this 4.5 here. So to make sure our scale matches what they've got, if we go to stat, number 1 is number 2 is sort. If we sort list 1, if we go back now to stat, edit. To remember to determine a class width, you have to have the maximum value minus the minimum value divided by the number of classes you want. So a minimum value is at 22, a maximum value is at 49. So if we go 49, so if we have 49 minus 22, if we divide that by 7, let's see what kind of scale they want us to have for our graph here. 49 minus 22 divided by 7. So let's say we get this 3.85, which is really closer to 4. So what they're saying is our class width should be more like 4. So if we go back to window, our X scale, we should probably change that to 4. See if it makes a difference in our graph. And notice how it does make a difference in our graph by changing it to a 4. So that does look a heck of a lot more like the second graph now. So that's all really was had to be tweaking, is you had to kind of match that 7 classes by actually making sure the class width kind of matched what they were looking for. So the other thing is, what's the mean and the standard deviation? So remember, if I go to stat, go to calculate, number 1, calculate, oops, we got an error, go to, so let me pause my video for a second, see what I got wrong here. So I got an error, so I try to figure out what was wrong with my error. I think I figured it out. So if I hit stat again, go to calculate, 1 variable statistics. List 1 is L1. We don't have anything in the frequency list this time, so this needs to be cleared. I think before we actually had some frequencies listed there. We don't have anything in L2, so we need to leave that blank. So if I hit calculate again, so our mean is going to be X bar, which is going to be this 34.86. So it looks like they're rounding to the 10th place. So that'd be like 34.9 would be the mean. The standard deviation is actually going to be a sampling. So we have to use S and not sigma. So see if we can find S. So S is going to be the S of X here. That's going to be the standard deviation of a sample. Remember, sigma is actually for the population, and we did a sample. So the standard deviation looks like that's going to be a 6.7. So that's the trick sometimes. Are they wanting the population, or do they want the sample? So remember, S stands for sample, and the sigma actually stands for the whole population. All righty. So hopefully you may find that useful in answering some questions in your homework.